The next sub question was rotating the xy plane by through 90 degrees, leaving z axis alone. So z axis is not rotated; it is kept as it is, and it has been rotated. So cos 0 now become cos 90. So cos 90 and sin 0 becomes sin 90. That is one. And here you can consider it as like mm, cos 90 now converted to cos 90 plus 90, that is minus sin 90, or you can have it as minus sin pi by 2. Already you have seen this 90 degrees rotation, same has been written for xy plane and leaving the z axis. So similarly you have rotation through here xy plane, then xz plane, and then yz plane. So whichever you are doing it last has to be written, that matrix has to be written first. So you can see yz written first, this is yz. So always this represent x, this as y, this as z. So here again x, y, z. So y and z where it intersects, only these points has to be changed by 90 degrees. Similarly, first yz you will be writing, then xz you will be writing, x you can see x and z. So this column, another values of identity is left as it is. Next is xy, you can see xy has been written and this identity matrix is left as it is. So you multiply and just find out the value, that becomes your rotation. Carry out the same rotation but each through 180 degrees. Here there you had seen it for 90 degrees, same repeat it for 180 degrees. So that was only. So this is not a graphical linear transformation, it is just linear differential equation. You have to find out a value A matrix, that is double differentiation, but the double differentiation of that vector should be vector itself. So you have to find the solution for this. Find two independent solutions to give a basis for that solution. So you have to find out two independent solutions to give a basis for that solution. So you have two linearly independent functions whose second derivative equals the original. So you have, do you have any polynomial that gives you the same two times of deriving twice gives the same value? So you don't have any polynomial, as you have one exponential function. You can see I have taken one exponential, another exponential as e raised to minus t, and one, because it has, we have asked if two vectors, so one vector u1 and one vector u2. If only one vector is asked, you can make use of this. If three vectors are asked, you can go for any other e raised to minus 2t. Not minus 2t, minus 2t will lead to 2, but you can use this minus 2t in an efficient manner. So here I have differentiation, double differentiation of this is et square, et square, that is 3. And here this double differentiation you get ut itself. So when you are getting the differentiation, twice the differentiation of the same function, so you have basis as e raised to t and e raised to minus t. So one more example, you can have a sin ht and cos ht. Sin ht, differentiation of sin ht twice leads to sin ht itself, and cos ht also leads to cos ht itself. So you can have two vectors. One is one that is u1 sin ht and u2 cos ht. So we have the basis with dimension 2. So one more problem that has been asked here is the cubes p3 to the fourth degree polynomial p4. What matrix represents 2 plus 3t? The columns of in the 5 by 4 matrix, you have 5 columns, 5 by 4 matrix, that is 5 rows and 4 columns. And A comes from, matrix A comes from applying the transformation. This is your basic of the transformation P1, P2, P3 and P4. So you have automatically 4 cos 5 So as we have solved it previously also, that is here I am taking the basis for this will be 1 0 0 0 and for this will be 0 comma 1 comma 0 0. Previous problems I have explained. So I am multiplying the first column with this because your base is this function becomes 2 3. Okay, your xy. So being multiplied, your AC1 becomes first column becomes this one, second column becomes this one. Here it was asked that 5 cross 4. So you are having 5 variables. This represents your constant. This represents the coefficient of t, coefficient of t squared, coefficient of t cubed, coefficient of t raised to 4. 1, 2, 3, 4 and this constant. So similarly, just write the matrix. So here we are assuming, I am assuming the matrix already. That is, this is 1, this is 1. I am not writing the basis function. I am just writing directly 1, t and t square. And because I know the basis functions for the constant is 1, 0, 0, 0. That same has been utilized 1. So you have 2 and one more basis for t. Both together we are writing this becomes AC1 after transformation. These are just the basics. Okay. So this can be done directly or you can find out the P matrix as we have done in the previous problems. And that also you can solve. And prove that T square is a linear transformation as T is linear from R cube to R cube. So this is also simple. This we know.